Hi, welcome to Module 8, Hostile Environments. Now we could call this module corrosion because largely we're going to talk about corrosion, but there are other hostile environments as well, for example radiation, which you might encounter in a nuclear reactor. In some ways this is the most important module of the class because it brings in all the other aspects or modules that we've looked at in class: fracture mechanics, fatigue, multi-axial failure. And the reality is that when you look at the failure of real parts in the real world, hostile environments and corrosion are often responsible. I think we saw in the introduction to the course that a large majority of the failures encountered by engineers are due to hostile environments and corrosive situations, often in synergy with fatigue, which we discussed in Module 6. So the goal for this module is to look at the synergistic nature of corrosion and fatigue, to review the different corrosion mechanisms and how they depend on the environment, the type of material you're looking at, and the microstructural mechanisms that occur in the material that often lead to embrittlement. Another title for this module could be embrittlement, because almost all the corrosion mechanisms we're going to look at are going to lead to embrittlement of the material, which basically means the material becomes more brittle. It will fail at a lower strain and often at lower values of stress as well. So we'll look at the mechanisms of embrittlement caused by corrosion in the environment, analyze the effect of these embrittlement situations on things like stress intensity factors, and then learn how to assess the service environment for a particular situation to know whether embrittlement is something that we need to be concerned about and thus test and design around.